Assalamu alaikum. Today I will revisit series parallel example, the one I discussed in a previous video. The question says Vs equals 46 volt and I want to find voltage and current of all the three resistors. First of all, I need to decide to identify actually if the circuit is series parallel or series parallel combination. So this is node number 1, node number 2, all of this, and this is node number 3. Since this circuit is more than 2 nodes, it is not parallel. Node number 2 and node number 3 connects 3 elements, so it is not series. It is series parallel combination. I have all resistors value are given. Voltage source also is given. So I will solve this problem by first finding R total, then I total, and I will go forward from this point. As you see, node 2 and 3 connect R3 and R2 along with the source with R1. So if I want to redraw this circuit, R1 voltage source, and then we have R3 here and R2 here, R3 and R2. If you see or label again, this is node number 2, this is node number 3, and this is node number 1. Now it is very clear. R2 and R3 are in parallel. And actually, when we think about it, look at it. At this part in the circuit, 2 and 3 share the same node, so they are parallel. Share the same 2 nodes, so they are parallel. So since these 2 resistors are in parallel, so R equivalent, I will call this as R equivalent 1. And I draw the circuit here. Sorry, this one should be R equivalent 1. We have only 2 resistors now. And if I want to label, this is node number 1. And this is node number, which number 2? Connecting R2 with these 2 resistors. So this is the equivalent resistance, and this is R3. From this circuit, it is very clear that R total equals R equivalent 1 plus R1, which is equal to 10 plus 36 or 46 ohm. Now I total equals 460 divided by 46, which is equal to 10 amp. We have this current flow through R1 and through the equivalent resistor here. So the current here is 10 amps, 10 times 10. So the voltage here is, this is the direction of the current, this is positive. Let me use different. Okay, I will remove that and that. So current here is 10 milli, positive, negative. 10 milli goes through R1, makes a voltage drop of 100 volt. Now the 10 milli, the 10 amp, sorry, I don't know, I'm just, looks like I attached to milli, but anyway, here we talk about amp. 10 amp times R equivalent, it is 360 volt. This is positive, negative, 360 volt. I will go back to the original circuit. This is the original circuit. So this voltage around, I'll go down, maybe use this one again. So this is positive, negative 100. The voltage between node here 2 and 3, this is node 2 and 3. This is node number 1, 2, 3. The voltage between node 2 and 3 from this simplified circuit is 360. So this voltage is 360. And this voltage also at this node is 360. How we found it? If you want to apply KVL at this node, at this loop, this is the loop. The first thing you see is positive, so it is positive 360, and then minus Vs plus minus Vs. Oh, so this is positive, negative. Yeah, correct myself. Plus 100 equals 0. Or Vs 360 minus 460 plus 100 equals 0, which is correct. So Kirchhoff's is applied at this circuit to find actually 360. Now, if you apply Kirchhoff's voltage law around this loop, I want to find, for example, the voltage of R2 and the voltage of R3. I will apply KVL at this loop and at that loop too. In this case, it is what? Positive 100, the one we calculated previously, plus VR2 minus Vs equals 0. Vs is the 460, so VR2 equals 360. What I want you to notice in this, I want you to keep in your mind when you look at this circuit, at the original circuit, or even this one, which is less messy after my handwriting, especially if I remove my handwriting. The voltage at these 2 points is the same as the voltage between these. It is the same voltage at R3. What if I add one more resistor here? Or one more resistor there? Still, these 2 points, the voltage around all this is 360. And around either it is 3 resistors or 1 resistor. Whenever we have a parallel elements connected in parallel, they share the same voltage. Whenever we have elements that connected in series, we they share the same current. So what you need to do, you need always to identify which part of the circuit is parallel, which part is series, so you can apply this simple rule. I will continue by finding IR2, which is equal to 360, the voltage we found early, divided by 90, and this is 4 amp, and IR3 equals 360 divided by 60, which is equal to 6. If you add them, I total equals I2 plus IR3 and IR2, which is equal to 4 plus 6 ampere. In the next video, I will continue looking at second example, series parallel example.